Here we're going to use right triangles to find trigonometric values. Trig values, these 6 here, sine, cosine, tangent, cosecant, secant, and cotangent, are the 6 trigonometric ratios or trig ratios or values, and all they are ratios of one side length in a right triangle to the other. So down here I have a right triangle, and this is theta. It just represents the angle. Theta can be either acute angle in a triangle. So let's say theta is this angle down here in the bottom right. That means that the side opposite to theta is over here because it's literally opposite from it. So this side would be the opposite side, where the side next to theta, the leg next to theta, would be the adjacent. Adjacent meaning next to. Now you could also argue that this side is next to theta. That is true. However, this longest side length here, the one opposite of the right angle, that's called the hypotenuse. And that is always the hypotenuse. If theta were to change and theta were to be up here, then this side would be opposite and this one would be adjacent. However, the hypotenuse is always the hypotenuse. All right, so the sine of theta is always the opposite side divided by the hypotenuse, and cosecant is just the reciprocal of sine, so it is the hypotenuse over the opposite. Once you find sine, you flip it to find cosecant. Sine and cosecant are reciprocals. The cosine of theta is the adjacent side divided by the hypotenuse, and the secant is the reciprocal of cosine, so it's hypotenuse divided by adjacent. And the tangent of theta is the opposite divided by the adjacent, and the cotangent is that reciprocal, the adjacent divided by the opposite. This is why at times people have said SOHCAHTOA. Sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent, and that little acronym is SOHCAHTOA. It helps remember these main 3. These other 3 are those main 3 reciprocals. In this example here, we'll find all 6 trig values or trig functions. I'll write the other 3 once we found these main 3. For this right triangle here, for this theta. Now theta down here is in the lower left, so 9 would be the opposite, since it's opposite of theta, and 12 is the hypotenuse. That does not matter where theta is. We do need to find this third side length, and we can use the Pythagorean Theorem to find that side length. So that little side length we'll call a, so it will be a squared plus 9 squared equals 12 squared. So we'll have a squared plus 81 equals 144. And so we have that a squared when we subtract 81 is 63. The square root of 63 will be the square root of 9, the square root of 7, because 9 is the biggest perfect square that fits in it. And then the square root of 9 is a 3, so a is 3 root 7. So this missing side length is 3 root 7. Now we can find the sine, the cosine, and the tangent of those 3 sides, or of that angle. So the sine of theta is the opposite divided by the hypotenuse. So it's going to be 9 divided by 12, which simplified is, when we divide both by 3, 3/4. The cosine of theta is the adjacent side divided by the hypotenuse. So that would be 3 root 7 over 12. The 3 and the 12 can both be divided by 3, so we don't need to write the 1 out in front. So it's root 7 over 4. The tangent of theta is the opposite divided by the adjacent. So it's 9 over 3 root 7. The 9 and the 3 can simplify, so it's 3 over root 7. Now we don't like a radical in the denominator, so we'll rationalize it. multiply both by root 7 to get 3 root 7 over 7. So we have found our sine of theta, our cosine of theta, and our tangent of theta. All right, I've made that a little smaller so we don't run out of room. Now what we want to do is find the reciprocals of these three. And so I do want to have these here just so we can see them. All right, first we want to do the reciprocal of sine. The reciprocal of sine is cosecant. And the cosecant of theta, once you've found sine, cosecant's easy to find because the cosecant of theta is just its reciprocal. So the cosecant would be 4/3. You can also think of cosecant as hypotenuse divided by opposite, 12 over 9, which is 4/3. I like to just find these main three and then you can find their reciprocals. The next one that we'll find is the reciprocal of cosine, and the reciprocal of cosine is secant. So we'll take root 7 over 4 and then write its reciprocal, which is 4 over root 7. We do have to rationalize this one more time. And that will give us 4 root 7 over 7. The last one that we'll look at will be the reciprocal of tangent. The reciprocal of tangent is cotangent. And we'll find the reciprocal of that, so we'll write 7 over 3 root 7. Again, we'll do the reciprocal, we'll rationalize. And so we'll have 7 root 7 all over 3 times 7, which is 21 in the denominator. 7 and 21 can simplify, so this final answer will end up being root 7 over 3. Now, sometimes it is easier to maybe just find the fraction instead of doing all that rationalizing, but it is good practice to get some of that rationalizing in. So we do have to do rationalization every time we have a root in the denominator. And there you have it. We used the Pythagorean Theorem to find a missing side length of a right triangle. One of them happened to have a root in it, which is great practice for rationalizing and finding the 6 trig ratios or values of theta.